Today again, Evan Snowman for Umaghloko, Making the Difference. We're doing our first video on metric trigonometry, which is the topic of compound angles. Okay, so let's have a look at this table here. Now I know that most textbooks use a different version of proof of the compound angles. I found this one a couple of years ago and really like it, so I'm going to go through with it. Okay, considering this inside triangle, this one that's inside the shape here, okay? Let's have a look at what happens if we play around with this shape. Okay, now we can work out again from, if we go back to trig, that if we had a triangle in this position, okay, and this was alpha and this was 1, then we can work out that this would be sine of alpha and this would be cos of alpha. So if we were to take a triangle in its standard position, where alpha is the angle and the hypotenuse is 1, we'd get that the vertical component would be sine of alpha and the horizontal component would be cos of alpha. So I would like to put that in here, therefore, that this would be sine of alpha and this here is going to be cos of alpha. Okay, now we're going to simply take the same idea and run it through a couple of times. Okay, if the angle is now beta, and we are now talking about this bottom triangle over here, okay, in the same way, okay, this side here, this side length over here, just this piece over here, is going to be cos alpha sine beta. And this bottom side here is going to be cos alpha cos beta. Okay? Because if we set it up and we say that, again, just as an example, okay, sine of beta would be this side, okay, the side we don't know, over the hypotenuse, which is cos of alpha. So then the side that we don't know would be simply the product of those two values. Okay, now if we take that same idea and we run it around the shape, okay, and we run it now into, sorry, wrong color. I now want to run into this top triangle, okay, and we look at what's going to happen in this top triangle. We're going to see that what we're going to get here now is that this is going to be, okay, hold on, we don't even need to know the angles. So let's just go and have a look here quickly at angles. So if this is going to be 90 degrees here in the bottom corner, so let's just do some thinking. If this is 90 in the bottom corner and this is 90 minus beta, then this here is a beta. Okay, so we know that that angle is a beta. So let's go and work this out now. We know that this is a beta size. So as a result, we know that therefore what we have here is cos of beta times sine of alpha. Again, apologies. And this one here is going to be sine of beta, sine of alpha, sine of beta, just this piece here on the right hand side. And if we look at the one that is left behind and just again play around a little bit, well, we're going to see therefore that this angle here is going to equal 90 minus alpha plus beta. And as a result, this angle at the top here is going to equal alpha plus beta. Okay. And again, when we run this trick around one last time, and we look at it in this orange triangle over here on the top left, what pops out is, well, hold on, if this is 1, so if this is alpha plus beta, then this side here is going to be cos of alpha plus beta. And this one on the left-hand side is going to be sine of alpha plus beta. Now, again, you know that because we have a rectangle here, okay, that the opposite sides are equal, which means that the left-hand side must equal the right-hand side. So we get our one key value, that therefore sine of alpha plus beta will equal sine of alpha. I'm going to choose to use a slightly thinner pen for the rest of this. Okay, times cos It's right a bit neater. Sine of alpha times cos of beta plus cos of alpha sine of beta. Now, we'll talk a bit more about this in a moment's time. Okay, and we get that, therefore, cos of alpha plus beta. Now, hold on, this is a little bit more difficult to understand. Because these sides are equal to each other, so I'm going to choose to write it as follows. Okay, so plus sine alpha sine beta would equal cos alpha cos beta. It must follow that cos of alpha plus beta would equal the difference between these two products. Okay. Now, the good news is that they can ask you to prove this. Okay. And again, there is a version in your textbook if you don't particularly like the one that I've got that I'm showing you here. But the other thing is, once all these formulae are on your formula sheet waiting for you. Again, just quickly, just so we can try and remember it. For the sine function, the sine stayed the same, whereas for the cos function, the sine changed. Okay. For the sine function, the products were opposites. It was sine with cos, whereas for the cos function, the products were the same, cos with cos. Okay, so again, for me, that's how I kind of remember it. But again, I don't need to remember it because ultimately these formulae are on the formula sheet. However, there are 4 formulae on your formula sheet. And so we can actually think about how to get the other 2. Okay, and again, if we then looked at this as being, for example, okay, sine of alpha minus beta, okay, and we try to think of that, for example, as being sine of alpha plus minus beta, okay, I'll leave this as an example for you to think through, okay, but what would that minus beta do inside these various things, okay, and what we're going to get is sine alpha cos beta, and as we said upstairs in the previous example, that the sign would stay the same, okay, cos alpha sine beta. And if we were to look at cos of alpha minus beta, we'd get cos alpha cos beta plus sine alpha sine beta. Okay. Okay. But these 4 formulae are given to you on the formula sheet. So again, I remind you, you do not need to learn them off by heart. Okay. You are expected to know how to derive given one of them, how to derive each of the others from that one that they gave you. Okay, and we'll see that in 1 or 2 of the questions that follow from here. But the key thing is that this is where these formulae come from. I hate my students just to get given a formula and say, there, believe me. Okay, so now I've shown you that these actually are the formulae. Okay, now here is quite a friendly little question. Again, asking you to do something in terms of sine of 36. We do not know what the size of 36 is. Very often they say to you, for example, they'll say to you, let sine of 36 equal k, find the values in terms of k. That's another way of asking this question. Okay, they didn't in this particular case, but that's another way of asking the question. So what we need to see is the relationship between sine 324 and 36. Now it is true that that 324 is 9 times 36, but we don't have any rules for timesing. Okay, we've got rules for adding and subtracting. So I'd much rather think about adding and subtracting. And so what I'm going to do quickly is have a look at what is, sorry, before I do that even, I'm going to look at what is 324 minus 36. And we're going to look at what 324 plus 36 is. Okay. Now 324 minus 36 is 288, I think it is, which doesn't help me because that's not a nice value. So that's actually not going to be overly useful. So I'm going to scrap that idea. When I look at 324 plus 36, I get 360, which is a nice thing. So that is going to set me, yep, that's the version I want to use. Okay, so I'm going to rewrite this therefore as 324 equals 360 minus 36. I'm going to use that version in my work. So here we go in the blue pen. This is actually my answer. Sine of 324 equals sine of 360 minus 36. I'm going to go get my formula sheet and look this up. Okay, and remember what my formulas say. And so again, if I looked at them there, I'd look them up. Sine of A minus B at the bottom there. So this would equal sine of 360 times cos of 36 minus cos of 360 times sine of 36. Okay. Now, we could have done this using straightforward cast diagram, but yeah, I'm trying to do it for you as though we were doing one with the compound angles. Okay. We know that sine of 360 is naught. Cos of 36 doesn't make a difference because it's going to cancel out with it's going to be multiplied by naught eventually. Okay, cos of 360 is the same as cos of naught, so that's minus 1 times sine of 36. So we know the answer is going to be negative sine of 36. Okay, and we have an answer that is actually in terms of sine of minus 36, and that should actually make me feel slightly warm and fuzzy because it's correct. Okay, now I know that I'm going to pick this question up in another video again, but I'm going to do the same thing now for this. Okay, so 72 minus 36 and 72 plus 36. Well, that is 108, which is not going to be very useful. Okay, and 72 minus 36 is 36 itself, which may not be overly useful, but it's definitely more useful than 108. So what I'm going to choose to do is going to see 72 as being 36 plus 36. So here I'm writing in black. Here's my answer. So cos of 72 equals cos of 36 plus 36 equals cos 36 times cos 36 minus sine 36 times sine 36. Okay, now at this point in time, I've got sine 36s, which make me happy because that's what they asked me to do, write things in terms of sine 36. But I've got now cos squared of 36 minus sine squared of 36. And at this point in time, I'm going to get a little bit stuck until I remember a side law which said that sine squared of theta plus cos squared of theta equals 1. Therefore, cos squared of theta equaled 1 minus sine squared of theta. And I'm going to choose to rewrite that cos squared of 36 in terms of this manipulation. So I'm going to get 1 minus sine squared 36 minus another sine squared 36. And so as a result, I'm going to get a final answer of equals 1 minus 2 sine squared 36. Now, I did say just before I did the sum that I will be doing this one again in the next video, but this is how you could do the manipulation if you didn't see the alternative. And again, the top blue one is how we know that the blue one is the reduction formula. We did that back in grade 11. Okay, you can see from the mark calculation that was meant to be fairly simple. But what I'm trying to show you here is how we could use the compound angle formulae to expand these ideas if we didn't remember any other shortcuts. Okay, next option. Okay, they give us a formula for cos of a minus b, okay, and ask us to derive a formula for sine of a minus b. Okay, so again, this is, as I said to you, one of the typical exam type questions. So let's have a look. What do you know about the link between cos and sine? Okay, we know that the link between cos and sine is that cos of a minus b is the equivalent of sine of 90 minus a minus b. Okay, so therefore, okay, we can see we can do this in reverse. For example, we know that these two things are co-ratios. Okay, so we know that these ideas are co-ratios. Okay, so let's have a look at what's going to happen. Okay, so let's actually go and rewrite it the other way around. Actually, this one needs an extra bracket, so let's write it the other way around. Okay, so we're deriving a formula for sine of a minus b. So sine of a minus b is equal to cos, silly me, silly person, okay, cos of 90 minus a minus b equals cos of 90 minus a plus b equals cos of 90, let's just write it down here as being 90 minus a minus b. Okay. Now, the reason I'm doing that is because they've given us a formula for cos of a minus b. Okay. So what we're now going to do now is we're going to write this as being, using their formula, this is going to be cos of 90 minus a times cos of minus b plus sine of 90 minus a, the first thing, times sine of minus b, the second thing. And effectively, which is slightly confusing, is I'm actually using 90 minus a as the value of a in the original formula, which is slightly confusing. And I'm using minus b as my value of b in my original formula, which is slightly more than slightly confusing, but we can handle it because this is a set question. We know it's coming. Okay, cos of 90 minus a is sine of a. Cos of minus b is simply cos of b. Okay, fourth quadrant, cos is negative, so cos in the fourth quadrant stays positive. We've got sine of 90 minus a, which is cos of a, and we've got sine of minus b, which is minus sine b. And all we need to do is bring that minus sign to the front of its term. So we've got sine of a cos of b minus cos of a sine of b. And all I'm doing is moving that minus sign to the front of its term. Okay, now it's a 6.4.2. So again, I'm seeing that this question notation is linking back to the previous one. Okay, so I'm not going to go onto a new page. I'm going to simply try and fit this onto the spot on the same page and try and see if I can't get these two things to work. Okay, so we've got sine cos plus sine cos, okay, which actually looks a lot like this formula here, okay. But we're going to realize that, hold on, okay, so this one is 6.4.2. We're going to realize that, therefore, this expansion sine of x plus 64 times cos of x plus 379 plus sine of x plus 19 times cos of x plus 244. Well, hold on. First thing I notice is that this value over here is bigger than 360. So I'm simply going to take 360 away from it. Okay, so what I've got here now is cos of x plus 19. what I'm seeing at this stage is that these two things actually now are the same, the x plus 19 and the x plus 19. So I'm going to try and keep that. And so as a result, I'm going to keep that plus sign of x plus 19 because they look the same. And I'm going to now try to find a way to make these other two look the same. Okay, and what I'm noticing here is that although they aren't exactly the same, the 64 and the 244 are out by 180. Okay, so therefore I can reduce this by taking away 180, and let's have a look at what's going to happen here. So I'm going to run it as a sidebar just because I quickly want to have a look at this. So actually just erase it, get some space here and let's write it a bit neater. So cos of x plus 244 is the same as saying cos of 180 plus x plus 64, which is therefore cos at 180 plus is third quadrant, so it's negative cos x plus 64. And not only am I happy because I've got the answer of negative, but I'm happy because that x plus 64 has become x plus 244 has become x plus 64, the same as my right-hand term. So again, my left-hand term. So sine of x plus 64, and I've got a cos of x plus 64. Okay, but again, we generated a minus sign here, so please don't forget that because of this generation of the minus sign here, this sign here is now going to change to become a minus sign. Now, that makes me really, really happy because now suddenly this line here and this line here are looking somewhat similar. Okay, sine times cos minus cos times sine, and we're told that that is equal to sine of a minus b. So if we go and look at this now, and we treat it, and let's just get some space again, move up the page a little bit, and we see this now as being, this is being the a, so there's the a, and this is being the b, and this is being the b. We're going to now get an answer of that this is equal to sine of x plus 64 minus x plus 19, which is equal to sine of 45, and we know that sine of 45 is root 2 over 2. Now, I've done that without looking at the rest of the question. The question says 1 over root 2. Now, again, if I was to type this into my calculator, it would tell me immediately that this is the equivalent of 1 over root 2. Okay? So, again, I'm now using the actual fact that the question has given me the answer as a means to check that my answer is correct. The fact that I got that answer while not actually focusing on it means that I'm highly likely to be correct in my working here. And again, what was the mark allocation for this question? I'm likely to have got 6 out of 6, probably got 10 out of 10 for this question. Okay, 10 out of 10, 10 out of 10 for a question in an exam out of 150 is almost a symbol. So that's really, really cool. Okay, I'm going to quickly look at the last slide. And okay, so again, we've been asked to simplify something down to a single trigonometric ratio. It's very similar to one that we've just done. Okay, and so let's have a look. So 5.2. Okay, sine 180 minus x, we know simply becomes sine of x. Cos of minus x, we know becomes cos, let's not rush, becomes cos of x. Plus cos of 90 plus x, well, it's the co-ratio, so it's going to become minus sine of x. Because it's the co-ratio, it's going to become minus. And because it's 90 plus, so cos in the second quadrant is negative. So it's going to become minus sine of x. times by cos x minus 180 okay, again, if here's my first quadrant and I take 180 away from it, I'm going to the third quadrant. Cos in the third quadrant is negative cos of x. So I've now got sine of x cos of x plus sine of x cos of x. And we'll look at this again, as I said, in the next video. But again, if I see this as being A, and I see this thing as being B, even though it's the same thing, what I've now got, therefore, is equals sine of x plus x, which is simply sine of 2x. We will look at that again, as I said, in a different format in the next video. Okay, 5.3, find the value of that. Okay, so we've got the same idea. Okay, we've got sine times cos plus cos times sine. So therefore we've got sine 3x times cos of y plus cos of 3x times sine of y. Well, this will equal sine of 3x plus y. Okay, they now tell us here that sine of 3x, or rather 3x plus y equals 270. So this equals sine of 270 degrees. And we know that a sine function does that roughly. So sine of 270 is -1. Okay, thank you very much for this video. As I said, we'll take this further and look at double angles in the next video. All the best.